tutorial 3 in this series of videos that are looking at the operation of the CPU. In this tutorial we're going to look at some of the registers that are used in order for your computer to work. Now, what we're looking at immediately on the screen is a slightly different variation on how the CPU can be conceived as a diagram. We're using this sort of W-shaped symbol, icon, to represent the ALU, or the arithmetic logic unit, using a rounded rectangle for the control unit, and a standardized memory location or memory icon for memory. Now these things are interchangeable, but if you work with the Welsh board or EduCAS, then the ALU symbol is important because that is used. Okay, so we've got our diagram here, and we can see the way that information flows in and out. So information flows between the CU and the ALU, and between the CU and memory, and between the ALU and memory. Okay, but what we need for this to happen are things called registers. Now registers are temporary storage areas. They don't actually do anything. They don't make anything happen, because that's the province of the CPU. So let's have a look. Well, this is just some of the registers that we have, and these are 6 registers. These are important, if only because the various exam boards expect these to be understood. So we're looking at the instruction register, the data register, the accumulator, the program counter, memory address register, and the status register. Now bear in mind that some of the registers often go by more than one name. Isn't that just the case in computer science? So let's have a little look. Well, first one that we'll look at is the instruction register. Now the instruction register lives, if you like, it is part of the control unit. So, well, what is the purpose of the instruction register? Well, the instruction register holds the instruction currently being executed or decoded. Yeah. So what is happening now, or what should be happening now, is the detail held in the instruction register, and this is sometimes referred to as the current instruction register, or CIR. Now, how these things work in practice, we will look at some of these in the next video. However, we're getting the theory out of the way for the moment. So on to the next one. Well, the next register that we're going to look at is something called the program counter. Now, misconception. The program counter does not count programs by any means. The program counter has a very specific purpose, and that purpose is to hold the location in RAM, or immediate memory, or main memory, if you like. These things go by different names, but they all mean the same thing. So it holds the location of the next instruction or data address in main memory. So whilst an instruction is being carried out, then the program counter will hold the next RAM address. So for example, if the next RAM address for the next piece of data or instruction is RAM address 1024, then the detail held in the program counter will be 1024, because that's where it'll have to go to next. Okay, so moving on. Well, now we're moving on to the data register. And this is part of memory. We can see that in the diagram. Data register has appeared. So, well, what does the data register do? Well, the data register stores the data being transferred to and from immediate access storage, RAM. It holds a copy of the designated memory locations specified by the memory address register. Okay, so it just holds a copy of the memory locations data. Okay, also known as the memory data register, or MDR, or the MBR, or the memory buffer register. So they were. So we've got a number of different initials to remember on that one. Okay, so that's what the data register does, but significant to that, of course, there is that we need to know what the memory address register does. So let's move on. So the memory address register is also part of memory. Yeah, so the two go together, the data register and the memory address register. So what does the memory address register do? Well, all the memory address register does is stores the memory address from which data will be fetched from the CPU. Yep, so if the data is at address 1,025,000, then that's the memory address. Or the address to which the data will be sent. So if the data has to go off to memory address 1,025,000, then that's where it will be, and that then will be picked up later so that the data knows where it should go. Okay, so moving on. Well, moving on, we're going to move on to the accumulator. Okay, so let's see what the accumulator does and where the accumulator lives. Well, the accumulator is part of the ALU, or the arithmetic logic unit. And what's that do? Well, the accumulator is sort of a clue in the word there. It's a mathematical operation. Yeah, and it's a temporary store, and all registers are just temporary stores. We must remember that. But the accumulator is a temporary data store used while calculations are being performed within the ALU. So if a value has been calculated and we're waiting for something to happen to it, that's where it will be. It will be in the accumulator. Okay, so moving on, well, the final register that we're going to look at is called the status register, and we can see that that is there as part of the ALU. Well, so what does the status register do? The status register is an unusual register. It's an unusual register because it holds, and again the clue's in the name, it holds information about the state of the processor, the status of the processor. Now, it's sometimes referred to as the flags register. So what's it do? Well, the status register forms a CPU if an instruction has resulted, for example, in an overflow error. Yeah, it will also hold other values as well, which we're not going to go into in this occasion. So we have looked at a number of different registers, all belonging in the CPU, and the instructions that we looked at were the instruction register, the data register, the accumulator, program counter, memory address register, and status register. Now you need to know what these registers are, what the purpose of these registers is, and we will look at how some of these are used in practicalities in the next session. Thank you.